on the computer.
This meeting is being recorded.
All right. So I am now recording. Just FYI. Okay. So today we're going to finish up section 2.1. We're just going to take a look at pie charts, and then we're going to launch into 2.2. We're going to talk about how we can organize our data into tables. We're going to do some histograms. I'm going to tell you the difference between a histogram and a bar graph, which will become important when you are doing your lab. We're also going to look at continuous data and how it's organized as well. And histograms look similar, almost exactly the same for discrete and continuous, with just a couple tiny little things. We're going to do stem and leaf plots, which are my least favorite types of plots, but they're part of things we have to do. So I'm going to show you how to do them. If you find a great use for a stem and leaf plot and what makes them super valuable, if you share that with me, I'd be so happy. You never know. I might learn something. The last, we're going to talk about the shape of a distribution. And then once I'm done with 2.1 and 2.2, I'm going to go over to how to do the labs. Now, obviously, there's already a video showing you how to do lab 1, but if you want to stick around and have me do it live for you, show you how to use it, we can do that. I will be doing that at the end. So that's what we're doing today. Should not take too long. With the lab on it, it ends up taking a little bit longer, but we'll be good to go. All right. Maybe? Okay. It's going to take a second. Looks like we've got a delay. So this data here represents the marital status of U.S. residents 18 or older in 1990 and 2006. So we're going to show a bar graph that shows both of these. It's going to be a side-by-side. So take a look at 1990, the never married, there were 40.4% of people were never married. And 40.4 million people had never been married. 2006, 55.3 had never been married. This probably would be more meaningful if it was a relative frequency, so we can compare percents, because that is more meaningful, but whatever. All right. Which is what we're going to do here in a second. If I keep my screen, I don't know why there's a delay. I think maybe my internet is not happy with me or something. Okay, so we're going to create a relative frequency. Maybe we're not. If we were completing a relative frequency, which our bar graph is going to show, you would take each value and divide it by the total number that there are. I'm not going to do that because I don't have them added up. But just remember, you take that column's frequency, or that, like I would take 40.4 and divide it by whatever the total number of people that were surveyed are. And I hate it that there's a delay. See, I already wrote that. Okay, hopefully it'll get better as we go. All right, here's our side-by-side bar graph. Notice that the light blue here is from 1990 and the dark blue is from 2006. I created a relative frequency because rather than comparing our totals to each other, I'm comparing the percent or the proportion of people in each category. So you can see that in 1990, there were a lot more married people, or the percent of people that were married was higher. 2006, the divorce were higher. Never married were also higher. So it's looking like marriage is not quite as popular as the years go on. I would love to see what 2020 looks like. It would be interesting to see more current information. I might have to look that up and use that in the future. But this is a side-by-side bar graph. Okay, moving on. So we're going to take a look at pie charts, if I can get it to go there. So you've all seen pie charts. You've probably seen hundreds, if not thousands of pie charts. It's a circle that's divided into sectors, and every sector is one category of data. The area of the sector is proportional to the frequency. So we would, divide up the 360 degrees of a circle so that the degrees were the same percent as each slice. I am not going to require you to make a pie chart by hand. I'm going to teach you how to do one in Excel, but I will not require you to do one by hand because that would be rude. You'd have to have a compass or something round. You'd have to have a protractor so you can calculate the angles. And it would be really fun for me, but not as much fun for you because I love doing stuff like that. Right, moving on. So once again, we're going to take the marriage data, if it'll get there. This is the 2006 again. And so we're just using 2006, and we're going to create a pie chart of all of this data in the different category. So here's, take a look. It's my lovely pie chart, maybe. Here it is. Okay, so what I like on pie charts, I like the percents to be on there. It's a lot more meaningful seeing the percents so that I know exactly how they relate to each other. So I usually put the percent on there. And you need to have some sort of a key saying what the colors are, but this is a nice, pretty pie chart. As I said, I'm not going to make you do one by hand, but we'll do it in Excel. Any questions or anything? All right. Maybe if they'll go to the next screen. So this data right here is the available cars in a household based on a random sample of 50 households. So basically, we asked 50 people, or basically the census asked 50 people how many cars they have in their house or in their household. And this is just raw data. I haven't done anything with it. No cooking yet. It is just the raw data. I'm going to put it in a table. Give it a second and you'll see the table. So here is the table. I did the frequency and I did the relative frequency. Since it was 50, once again, I did 40 divided by 50 to get 0.08, or 8% of households have 0 cars. For 1 car, 13 divided by 50, 26% of households have have 1 car, have 1 car. I'm sorry. And then moving on down the list. So notice only 2% of households have 5 cars, or 1 person out of the 50. That's a lot of cars. I think my son-in-law might have 5 cars. He's always fixing them up and flipping them. He finds like super good deals. He had an old Suburban. It was 80 something. And that thing had 584,000 miles on it. Seriously. And he bought it for $150. And so then he bought it, he fixed it up, and he sold it for $3,500. And that's what he does all the time. So it's pretty cool. I see some really cool cars coming through his yard. All right. Sorry about that. Moving on. Let's talk about a histogram. Guy's over there laughing at me. It's okay. He's like, yep, I know a guy like him. Or maybe you are a guy like him. Everyone knows a guy like that. Everyone knows a guy that finds cheap cars and buys them and fixes them and sells them. Everyone knows somebody like that. All right. So the histogram looks a lot like a bar graph. Once again, you're drawing a rectangle for each class, just like we do, or each category, just like we do with the bar graph. Just like a bar graph, the height of each rectangle is the frequency or the relative frequency. This is the difference right here, this bottom one. And there's a delay, but it's going to get there. So each of the widths of the rectangle are the same, but the rectangles touch each other. The rectangles are going to touch each other. So they're going to butt up right against each other. I'm sure you've all seen these bar graphs where they touch each other. That's a histogram. They're really not a ton of difference. However, we use histogram for discrete variables occasionally, but most of the time we're using them for continuous. We generally don't use bar graphs for continuous. We use histograms. All right. Any questions before I move on? Are we okay? And make sure you holler at me if I move too fast. Okay. Once again, this is the data from number of cars. As before, I have my relative frequency there. So this is what a histogram looks like for discrete data, if it'll go there. With discrete data, your number of the category is directly in the center underneath the bar for the histogram. So this is only for discrete. That number would be right underneath of there in the middle. And then everything else is the same. Notice my bars are touching each other. And make sure you labels. Don't forget your labels. Labels are important. Label your axes. Put a title on the top. It's muy importante.
And so this histogram would only be used for continuous.
Well, this one's particularly
Is that what you were saying?
discrete. This one is for discrete. We don't frequently
Discrete.
use histograms for discrete, but it's not like you can't. But most of the time it's
Okay.
for continuous. This one, I mean, number of cars in the household is discrete because you're not going to have 2.75 cars. So it's discrete.
Right.
But you can tell it's discrete because I put these in the center rather than on, you'll see how they look with, you'll see how they look in a second with the continuous. All right, here's the relative frequency. It basically looks this, that's not the, it will be, there it is. It looks basically the same. It just has the proportion of cars in each, of each in proportion of number of cars in each household instead of the count of them. Right. So we're going to talk about our continuous data, but I need to give you some vocabulary. So classes are the categories into which the data is grouped. Another thing we call them, whoops, hold on, go back. Along with classes, sometimes we call them bins. They're used interchangeably. The word bins or the word classes, they're interchangeable. We use both of them. So if I say bins, I mean classes. The Excel uses the word bins. And I am not going to require you to make a histogram by hand, but you will have to, I think that in my open math, I think there's one where they want you to like draw the lines. I can't remember. I don't remember if it's still in there or not, but I'm not going to make you do one by hand. I will show you how to do it in Excel. So when we have a large number of different discrete values, or if it's continuous, we create the classes by making each of our rectangles is going to represent an interval of numbers. So it'd be, so let's say that we were talking about number of cars on car lots in the US rather than cars in a household. We would have big ranges of values. So I would probably have like for a small range for like smaller car lots, like 0 to 14. And then I would have 15 to 29, and then you'd have 30 to 44. And all of your bins would represent 15 different numbers. So if you have a continuous data or discrete data that is a large range of numbers, you would make them into classes or bins. If you have continuous data, you have to use classes or bins. And I'll show you what that looks like in a second. Maybe. There we go.
Melissa, could we assume that all this, like the vocab's probably on the test?
So I don't do a lot of, I mean, I don't have a whole lot of vocabulary questions. So usually if it's going to be a vocabulary thing that I'm going to specifically ask you what it means, I'm usually going to tell you, hey, you might want to know what this means for the test. Like, for example, when I said continuous and discrete, when I said, hey, this could be on a test or a quiz, you might want to remember this vocabulary.
Okay, thank you.
You're welcome.
Can I
Usually if
piggyback
it's-
on that question?
What was that?
Can I piggyback on that question? Will you want us to be able to define in our own words or recognize the definition when we see it?
So okay, on the quizzes ask you things like, and I don't think it necessarily, like, for example, I believe that the quiz, I'm going to give you, this is really good reason to watch this video or be in this class. I believe the quiz says something like, give me an example of a continuous variable about kindergartners. I'm making something up. And then you would say something like, the amount of time a kindergartner naps, the length of time a kindergartner naps each day. That would be an example. So you would just have to give me like an example of it. I'm not going to say define this. I'm going to want you to give me an example that represents that. Does that make sense?
Got it. Yes, thank you.
That's not the exact question on the quiz, but there's something like that. So,
Okay.
or I might say something like, which one of these is an example of a continuous variable? And you would have to choose it. That's another, could be. All right. Good questions. So this data here represents the number of persons ages 25 to 64 who are currently work disabled. So I have the age of the people, and notice I have ranges of age, 25 to 34, 35 to 44, 45 to 54, and 55 to 64. So these are my bins or classes. So these would be my bins or classes. Is this, each of these is a bin. And then these are my frequency here on the right. That's the frequency in each of those bins. How many are in each of those bins? So the lower class limit is the smallest value in that class or bin. I'll also write the word class or classes. So the lower class limit is the smallest value within the class. The upper class limit is the largest value in the class. So the class width is the difference between the lower class limit of two bins together. So for example, I did 35 minus 25. So that shows me I have 10 in each bin. Now these are really easy numbers because it's obvious it's 10 in each one. You can just look at it. Sometimes we do weird things with decimals or whatever, but you're always going to choose your own bin size. I'm not going to, Excel sometimes does funky things with bins, and most of the time you're just fine. I'm just fine with just saying, I'll leave it there. It looks good. Sometimes they do weird bin sizes, and you're just going to use your own best judgment to decide if you like it or not. You'll see once we get there. So this class width is 10. 10 is a good one. I don't remember if it's here or no, it's on the next screen. Second here, maybe. See, now my iPad doesn't even want to go to the next screen. Man, issues like crazy. There we go. All right. These are the time between eruptions in seconds for a random sample of 45 eruptions at Old Faithful Geyser in Wyoming. We're going to construct a frequency and relative frequency distribution of the data. So what I'm going to do is I'm going to put them into bins because this is a lot. And because it is time between eruptions, this is continuous data. Time is always continuous. That's just a given. So our smallest value is 672 and our largest value is 738. I look for pretty numbers, which they say convenient numbers, but I look for pretty numbers to make the bottom of my class. That way I'm not starting at 672. I want nice pretty bins. So I'm going to make my lower class limit 670 because that is a pretty number right around the beginning. And it will include my 672. I'm going to make my class width 10 because it's a good class width. Let's see what happens. Maybe. There we go. So these are the bins that I've chosen. My lowest class starts at 670 and goes to 679. That captures that lowest value and a few other ones. The highest class, the top one is 730 to 739. That captures my largest data value. So you need to make sure that all of your data values are captured. But now I have these nice pretty numbers. I'm not going to be upset with you if you decided to keep your lower class limit of the first bin at 672. But personally, I like pretty numbers. So there you go. So this gives me my classes. I have 1, 2, 3, 4, 5, 6, 7. So I have 7 bins. And the next page or a couple pages from now might contradict me, but generally you don't want a ton of bins and you don't want too small. Because if I only had 2 or 3 bins, it's not going to separate things enough so that I could really take a good look at the data. Plus, if I had, let's say I had like 50 bins, that's just too much and it's going to be cluttered and weird. So you want it to be like 5 to 12 bins generally. This is kind of a rule of thumb, not an absolute, because statisticians don't deal with absolutes. Everything is kind of ish or approximately or kind of or whatever. Trust me, it's annoying, but it is what it is. So 5 to 12 is a good number for how many bins you have. Right. So I made a frequency table. I made a relative frequency table. And this is my distribution. Bless you.
Thank you.
So I have my nice pretty table and I'm going to show you my histogram. But maybe not. So I'm going to redo it now and I'm going to make my bin sizes smaller. Hold on, wait, I went too far. Okay. Sorry about that. I wish that it wasn't a delay. I made my bin sizes smaller. So here it is, just a second. My bin sizes are now 5. My bin width is now 5. Now I'm going to show you exactly why we don't like this one. You don't want to have a whole bunch of empty bins right in a row. It's just not pretty. We like things to be pretty. We like it to be visually appealing. Plus, it's a whole lot of bins. It's going to give me way too many bars on my histogram. And as I said, this is just kind of rule of thumb, and it's what's visually appealing. What is the best way to represent my data? And there is no absolute. So I'm going to show you the histograms. Oh, I guess I won't. I'm going to show them to you in a minute. I forgot that these extra ones were in here. Okay. So here's our guidelines. I don't like the way they do some of the stuff here. So I'm going to tell you my way and you can decide if you want to do things my way or their way. This is from our textbook. So as I said before, when we choose our lower class limit of the first class, you find the smallest observation and then find a convenient number slightly lowest than the smallest observation. Either use the smallest number or use a convenient number slightly lower I say a pretty number. So find that smallest data value, then find a pretty number right below it. That's how you get your lowest class limit or the lower class limit. This is not the way I find my lowest class that I get my class width. I never do this. I lost some equal signs. They disappeared. There we go. I don't do this. So our textbook recommends that you determine how many classes you want, and then you take your largest data value, subtract the smallest data value, and divide it by the number of classes that you want. And that'll tell you your class width. I don't do this. What I do is I decide my class width, and then it will determine how many bins that I have. I will take a look and I will say, oh, I have about 50 data values. I'm going to make my class width 5, or I'm going to make my class width 10, and I will decide what I want it to be, and I will see if it turns out nice when I do that. The reason I don't like the way that they do it is because you end up with weird class widths like 7 or 7.5 or something like that. And I just don't like it. I want something pretty. I want nice numbers. So if you want to do it their way, go for it. Otherwise, just choose a class width that you like and then take a look at the histogram that was formed because of it and make your adjustments that way. Questions? All right. Moving on then. I guess we're going to get our other histogram in a minute. All right, so this data table if the regular textbook, it's on page 79. I don't know where it is on the other ones. It doesn't really matter. These are the rates for mutual funds in different banks. And so these were just all of the 5-year rate of returns as of 2014. And so I just collected all of this data. I created a frequency distribution and relative frequency distribution. I made my class width 1%, and it looks okay. I mean, I'm not super big fan of these two blank ones right here, but other than that, I mean, it looks like it's okay. It's kind of a lot of classes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I guess 12. 12 works. So, I mean, it's kind of a lot of classes, and I have a couple empties, but I don't know that I can avoid that because it's, I mean, it's over 2% different. So here's what my histogram looks like. Now, Excel chose my bin widths for this histogram before the update that happened. I created this histogram before there was an update that allowed me to choose my lowest bin and to choose my bin width. So this just starts with the lowest value, and there should be the word frequency here. And there should be a label here, interest rates or rates of return. So there should be, I mean, there should be labels here, and I didn't label it well. I just wanted you to see what an Excel histogram looks like, and it's pretty, kind of, almost. But so notice some things that I want to show you. I wish I knew what happened to those other histograms because I don't like this. And Nora, I'm going to flip to another screen real quick here, and I'm going to draw an imaginary histogram here, or draw one based on that other data. Give me a second. Give me a second here. How come I can't get to my next screen? Okay, here we go. I'm going to go back to that other data, and I'm going to create a histogram because, and it's not going to be perfect, but I just want to kind of show you what it's going to look like. I lost a slide that had the histograms for the eruptions, and just watch, it's going to show up later. Normally, when we have a histogram, the way that it is labeled is it is only labeled with the lower class limit. So take a look. I'm gonna, oh, it's supposed to be 2. So I'm gonna put 2, 4, 6. This is not going to be beautiful, but I kind of want to give you an idea of what that looks like. Just keep. Shoot. It just did that. I hate when I do that. Everything erases when I do that. Okay. Once again, I'm going to label these 2, 4, 6, 8, 10, 12. Okay. So the way
And that's the frequency.
that's
right?
the frequency right here is frequency. I'm just going to do frec. And then our lower class limit was 670. So I'm going to I have to do a break in my graph because you're never supposed to start a graph anywhere other than 0. But I'm not going to do 0 to 10 and then 10 to 20 and then 20 to 30. So I put a little break in the graph. That's just what that is. It's saying this part of the graph was cut out. And then my lower bin right here is 670. That's where I started. And it goes to 2. And then this next one starts at 680. And that's 0. My next one starts at 690. And it's going to go up to 7. Pretend that these are all the same width. And then the next one starts at 700. It goes up to 9. They actually look almost the same width. I'm not doing a terrible job. And this one goes to 9. To 11. And then the last one goes to 7. And then usually we'll still have the last one, even though there's not a bin there. So we're only labeling the lower class limits. This is a 0, not a. And this would be eruption time, time between eruptions. Okay, I'm not going to label the top. I just wanted you to see what a nice histogram would look like with the lower class limit. So Excel will not label things the way we like things labeled, but I just wanted you to give an idea of what it looks like when one is labeled correctly that's done by hand. So only lower class limits labeled. And also when you're reading them in My Open Math, I wanted you to have an idea of what's happening. Class limits. Yes.
And so a graph always starts at 0, right?
Yes.
I'm assuming on either end, you're going to go left or up and down. It's always going to be a 0.
Yes. So
That's
right, like right here, down here, this is 0, even though I didn't label it. Wait, hold on a second here. There we go. So that down there is 0 on the y-axis. Unless you put a break in the graph, it starts at 0. And I mean, I would, if you were doing one, Excel's not going to do a break in the graph. It's just, I can't draw. This is one of the things I can't do. I cannot draw one without a break in the graph, because I know as my students love it at the high school, love it when I say it's BS when you don't. That's called bad statistics. It's BS, bad statistics when you don't put a break in your graph. Clyde swore in class. No, I didn't.
I do have a question. I'm kind of like confused on that class part. You see
Uh-huh.
the numbers that you put on the bottom,
Yes.
right? The bins.
Yes.
And so the numbers are underneath that blue line. That's representing that the line, like I wish I could point at it, but that's directly above the number, or is
So-
it like the whole rectangle part?
So it's saying that this from here to here.
I can't see, sorry.
Okay, just a second. There you go.
Okay,
So from there to there is 670 to 679.
I see. Okay.
And then,
Okay,
yeah.
sorry.
So
Okay,
that
thank
the
you.
width of that represents 670 to 679. Does that
Thank
help?
you.
That help?
Yeah.
Okay,
Thanks.
you're welcome. Anyone else
And
before?
so
Go ahead.
this is a histogram due to the fact that all the bars are touching.
Yes, plus since
Okay.
it is continuous data, it's very, very, very rare for us to use continuous data on a regular bar graph. Very, very rare. Notice that I don't say never, because as I said, statisticians don't deal in absolutes, but it really does not happen much at all. So if you're using continuous data, you pretty much have to use a histogram. Does that help at all?
Yep.
We good? Okay. Hold on here. All right, I'm going to get off this screen and we're going to go to stem and leaf plots. So as I stated before, I would love it if anybody could give me a good reason why we use stem and leaf plots. They're my least favorite visual representation of data, but I'm going to teach you them. You are probably going to have to read some in your homework. I'm not going to test you on stem and leaf plots, but I think the homework has a question or two on it. And so I'm going to give you an overview of how they work and you can make your own. Uh-oh. Oh no, I hate when I do that. I just touched the plug and it did weird things. I know it couldn't be complete. Are you guys still there? Just making
Yep.
sure.
Yeah.
I don't know why my iPad decided it didn't want to work anymore. Okay, I have to stop sharing my screen for a second because my iPad decided to wonky. I think I'm gonna see if I can save or pause. Believe me, I don't even know if it'll let me. Okay. Oh, here we go. Recording.
This meeting is being recorded.
Okay. Sorry about that. All right. Stem and leaf plots. So the way what we do with stem and leaf plots is we break apart the numbers so that we have part of it in the stem and part of it in the leaf. For example, for the number 147, we would have 14 as our stem, and then 7 would be our leaf. And I'm going to show you what this looks like. It's a little bit confusing. So let me show you. I'm going to get some data.
So why you do that in this situation? What would be the difference between using like 1 as the stem and 47 as the leaf plots? I guess you're gonna let us know, but
Yeah, because, okay, so if I was dealing with hundreds, so if I had like numbers between, let's say 100 or 0 and 1,000, I might do 1 as my stem and then 47 as my leaf. But if I'm just dealing with all numbers that are like, 100, 110, 120, 130, 140, like that, then my stems would be 10, 11, 12, 13, 14, and then my leaves would be after those. So let me
okay.
show you and maybe it'll clarify it a little bit. So the stem's going to represent the integer portion or the digits, the ones place. Oh, wait, no, wait, when we're looking at so if we have a decimal, like for example, with the interest rates, then the integer portion would be the stem and the decimal would be the leaf. And I'm going to show you that as well. So hold on a second here. So here is my geyser data. So I reordered them because we want them in order from smallest to largest when we finally have our stem and leaf plot. So I reordered them. Sometimes we'll put them in there just like willy-nilly as raw data, and then we'll fix them afterwards. But I just decided I didn't want to take all of that time. So what I did was I spent a little bit of time actually ordering them from smallest to largest so that this is going to make my stem and leaf plot just a little bit easier. So let me show you how this is going to work. And I'm not going to do all of these because this is 45 numbers. Well, maybe I will. Okay. So here's my stem and leaf, just the stem part. I made my stems 67, 68, 69, 70, 71, 72, 72, and 73. The reason I have two 72s is because if you have a significant number that fits with one stem, sometimes it ends up with that leaf being really long and harder to find certain numbers in there. So we'll split them in half and make 2 leaves out of it. So let me show you what this is going to look like. So I have one value that's 672. So I just put the 2 right there. Then I have a 678. So 678. I don't have any more that are in the 670s. Now I have I don't have any in the 680s, but I do have a 695. I have another 695. Then there's another one. 696, 698, 699, and 699. You repeat them if you have repeated. And you're just putting the ones place there. Now I'm at 700. I have 700 twice. I have 702 twice, 703 twice, 706, 708, 709. They have to be in order from smallest to largest, and you make sure to take into consideration every data value, even that repeats numbers. 711, I have that twice. I have a 713, 2 714s, a 716, a 718, 719. So with the 72s, I'm going to go up to 75 or 725. Wait, no, 724. And then 725 through 729 will be on the other line. So be 0, 1, 1, 2, 2, 3, 3. Go down here and do 5, 6, 6, 8, 9. Then lastly, I have the 3s. 1, 3, 5, 5, 6, 8.
And so because these are all just in the one spot, we don't have to put a comma in between them. It
No.
would just, you would still just know that it's 695, it's 695, it's
Yes.
okay.
So now what I'm going to do is I need to have a key. So whenever you do a stem and leaf plot, you need to have a key. And so my key is going to, you grab any random one. It does not matter which one you do. I'm going to do this 6, 9, 5. And this is just a line. Represents 695 seconds. This is my key. And of course you'd put a title on this. So you'd put like, let me see, time between Old Faithful eruptions. You have to put a title. And that's what a stem and leaf plot looks like. This is not my favorite. I have not found a good use for them, but if you like them, go for it. And if you find a good use for them, I'd love to hear about it. I would love to be able to say to someone, to my future classes and say, you know what? A really good use for stem and leaf plots is insert it here, whatever it is. So I would love that, but I have yet to find a really good use for them. Questions about these?
So you said you have the little arrow on the side for the 72, and that's supposed to be the split, right?
Yeah, I mean, the arrow doesn't have to stay there. I just put it there because I was talking about it. So yeah, I split them in half because the 720s were really long. And so I split it in half and half of them went to the top and the other half went on the second one. And you don't have to use a split if you don't want to. Sometimes it just makes it really long.
Okay.
Other questions? Right, moving on to so here we have the unemployment rate, and I don't know what year this is, but the unemployment rate in all 50 states. So my stem and leaf plot, what it's going to look like is the integer part. So the part before the decimal is going to be my stem. And then the tenths place will be will be the leaf. So let me move and show you. So this is I just put them in there. I threw them in there. This is the raw data. I have not organized it yet. Do not ever leave it like this. It needs to be in numerical order, smallest to largest. So here it is fixed. And then you make sure that you use a key. And I'm just going to use any random thing. I'm going to do 53. Stop it. 5, 3 represents 5.3%. So you need to tell with the key what a number means, what one entry means on your stem and leaf plot. The key is important.
Does it have to, can it be just any one of those numbers? You could say 7.5% or
Yep. You just choose one.
okay.
Choose any random one you want. I just always just grab one. I usually pick one out of the middle just because I'm weird. Right. Any more questions? Right. We're going to talk about shapes of distributions. This is going to go quick, and then we'll do our lab. I would say maybe we have 10 minutes left, maybe 15 max if there's questions. So just trying to give you guys an idea of where we are. All right, so sometimes when we talk about a variable is we talk about the way it's the shape of its distribution. So it's basically what the graph looks like when it's graphed. So what it's going to look like when I make a histogram out of it. And it's going to turn into different things as we move forward. But today we're just going to talk about what it looks like when we make like a histogram or a bar graph of our data. So I'm going to show you the different shapes. You definitely will need to know these You'll need to know when the different skews and normal and all of that. So this is something that you're going to need to know. So this right here is called a uniform distribution. So that's evenly spread across. Sometimes it's not exact. Now this one is exact. But as I said before, statisticians don't deal in absolutes. So sometimes it is mostly uniform. So I'm going to get a blue pen because blue seems to represent this better. So sometimes I'll have like a couple that are slightly up, or maybe I'd have like this one was slightly lower. But if it is pretty close to uniform, looks almost perfectly uniform, we would still call it uniform. We might say something like it's mostly uniform or roughly uniform or something, because no absolutes, we like our adverbs. So a nice pretty rectangle like that would be uniform and symmetric. It's a uniform distribution. Okay, move on. This right here is bell-shaped, also called normal. This is bell-shaped. So if I drew over top of it, I have a nice pretty bell. It's got its bump in the middle. Once again, it doesn't have to be perfect, but if you have basically a nice bell shape, the tails on both sides, this is a bell-shaped, symmetric, normal distribution. Bell-shaped or normal is good. I will accept either bell-shaped or normal if you see it. This right here is skewed right. When I first learned skewed right, it really annoyed me and I couldn't wrap my brain around it. But just think about where the tail is. Since I have the tail over here on the right, it is called skewed right. So the direction of the skew is based on where you have that tail. Most of my data is hanging out on the left, and I have this tail that's skewing it right. This one right here, you guessed it, skewed left. Got this tail over here on the left. Most of my data is over on the right, and my tail is on the left, so it is skewed left. Okay, I have a little test. You can just say these in your brain. I'm going to test you, and everybody's going to get an A, even if you get them all wrong. All right, here we go. First thing, what do we have here? Think in your head, what kind of a shape do we have?
The bell.
Yep, this is bell-shaped. It is normally distributed. It is bell-shaped. It's nice, pretty bell curve. I could put a nice bell over top of it. Mm-hmm. This one's kind of cool. I like this one. Shape do we have here?
Skewed right.
Skewed right. Good job. We have our tail over here on the right. It is right skewed or skewed right. Both are completely acceptable, whether you say right skewed or skewed right. Exactly same thing. Right. Put that here. Tail is on the left. It is skewed left. Nice, pretty bell curve, or not bell curve. It's nice, pretty skew on the right, and its tail over there. Most of our data is over on the right. So our tail is on the left, skewed left. I might have said the wrong word. Sorry. Skewed left. Skewed left. Final one. I bet you can guess it before even seeing it. It is
Flat.
It is uniform.
Uniform.
Uniform. I like flat.
Okay.
I would love to have a flat, call it a flat distribution.
It's uniform.
It is a uniform distribution. It's uniformly distributed. All right. So this is the end of the lecture portion before the lab. So that is all of 2.2. You should be able to do both the 2.1 and 2.2 homework after this. I do real quick before we do the lab, I want to point out, so there's questions in 2.1. I've already gotten a couple messages about it, and that are going to require you to dig way back into your memory on how do I calculate percents. So basically what it does is it has like several percents. I'm going to go to the other screen. It has a pie graph. This is my perfect pie graph. And it says I'm going to do this too. So it has different like housing, food, utilities, all of that in your pie graph. And it'll say something like, I spend $1,600 on housing, and then housing represents like 23% of my income or my monthly budget. What is my total monthly budget? This is something that's going to require you to dig back into your memory banks and think about how do we do percents. So remember that percents are part over whole equals percent over 100. At least this is one of the ways I teach it. The other way I teach it, I'm not even going to go there. So this is a part of my monthly budget. I don't know the whole monthly budget. I know that that's 23% of my monthly budget. And then you just cross multiply. Now, this is not the only way to do this. This is just one way. So you would just do your cross multiplication, and then you would just solve for X. So I would have 16,000 equals 23X. And then you would just math it out, just divide by 23. And whatever you got would be your monthly budget, your entire budget. So this is that type of problem shows up in 2.1. So if you get there, that's what you're going to need to do with it. And it's just,
Is it
yes, go ahead.
23% or 0.23?
Because I did 23 over 100, that is basically changes it to that decimal.
Okay, I see.
Yeah.
Okay. Yep.
Because you could always do it like this, 1,600 equals 0.23.
Right. That's kind of how I did it.
Yeah, it's the same thing. Okay.
Yeah.
All right. This is just like basically it's the way that it's taught. I believe it's still the way it's taught in Math 20. And it's the way that I taught it when I taught sixth graders 1,005 years ago. I think they learned that. I think they still learn this. They might have moved it up higher, but it's not something that stays with us if we don't do it frequently. It's one of those things that is in some weird folder in the back of your mind that you don't open a lot. So you're going to get a problem like this and be like, wait a minute, she didn't teach us this. It's like, no, because for some reason we're expecting you to remember every math you've ever learned for your whole life. And if you're not a math teacher, you're not going to do that. So,
well, fortunately, I have Doug Gardner as my core rec. So
love him.
He ingrained this in your brain.
Did he already do this with you guys?
Yeah, I had a class with him last night, and we went over percentages and things like that. And so,
Perfect. I love Doug. Doug is awesome.
I do have a question though on because I'm on homework section 2.2.
Okay.
And I mean, I know the questions aren't going to be the same that you have, but I mean, I'm literally on the second question, but it's asking me the frequency of a litter of cats having at most 4 kittens, but maybe I'm just not reading the question right, or because I understand the graph.
4 kittens means that you're going to have to add together 0 kitten or 1 kitten. Plus 2 kittens.
Okay.
Yeah.
I get it now. I got
it's
it.
Okay. It's common that I always get asked that question 3 or 4 times. So I'm glad you asked it, because now everybody in this class is going to be like, I remember that question from class. So good job.
Right.
All right. Are we ready for the lab? Okay. I'm ready for the lab. I'm going to get rid of the iPad stuff because maybe that'll speed things up a little bit here. Let me see if I can close this out. Okay. All right, the lab, here we go. So I have random data. Most of mine is made up. And so yours will be real. Mine is made up just because I'm the teacher, and sometimes I do that. Because can you imagine every time I make a new key having to ask my friends and family information? That would be fun. Okay. So the first one we're going to do is we're going to this is the categorical data. So remember, categorical data is data that is generally words, either that or it's numbers you can't do math with. So my population here is friends on Facebook, and I asked my mythical friends their favorite colors. So what you're going to do here is make sure you list your raw data over here on the left. Just put the raw data over here. Also, make sure you tell me what your data is. I can't tell you how many times I've gotten labs turned in and I didn't know at all what the data is. So make sure somewhere in there you're telling me what it represents. Even though it does ask me that, sometimes I don't get that information. So this is favorite color, and my population is my friends on Facebook. Now, this says, why are you interested in the population and variable? If you're not interested, not a big deal. However, if this is something really interesting to you, I would love to know why you're interested in it. But if you're not interested, I'm not going to be mad if you don't care. If you just did it because this is the lab, I don't care. It's okay. But do tell me what variable you're studying. I'm studying my friend's favorite colors. Most of the time in categorical, you're not going to have units. So it's not a big deal. Make sure you just type in there that there's no units. Most of the time, categorical is not going to have units. And when it says, why are you sure that your sample data is categorical? You need to refer to the definition of categorical and explain to me why you know your data is categorical. So whatever that reason is, however you know, I want to know your knowledge. And then how or where did you get your data? So if you got your data from asking friends on Facebook, write that. If you got it from a website, I want a link to that website, or say, I got it from NFL.com, or I got it from the US Census website. So be specific about the website. And I can't emphasize this enough. Google is not a source. Please do not say, I got it from Google. Google is not a source. Now, I'm completely okay with you using Wikipedia because this is not a research paper class. I'm okay with Wikipedia. Wikipedia is fine, but Google is not a source. Google is.
How about Barstool Sports? Is that
Yeah. So
accredited?
I don't care if things are accredited, but Google points you to sources. It isn't
Right.
a source, but if you say you got it from that site, just name that site down there. Say, I got it from Barstool Sports. That's perfect. Love it. So I just don't want you to say Google. That's the biggest thing. Just like Pinterest isn't a source. People
Do you
say,
really want us to figure out people's favorite color?
no, this is just mine. This is just what I chose. You can choose whatever you want, whatever your categorical data is. But I just chose favorite color because that's just what I chose. But I want you to choose something you're interested in or whatever you think of. As I said, I've had people go to their closet and just choose the first 20 items in their closet. It doesn't have to be something you care about. Just choose something. Or you can,
So,
what was that?
oh, I was gonna let everyone know too that we spoke kind of before class, before everyone was here, that she was asking for at least 20 data points for each of these, but the number beyond that can be, you can do 100 data points or 150 data points. It's just a 20 point
25,
minimum.
you can do 30, you can do 50. It doesn't matter. 20 is the minimum. Anything above 20 is fine. I mean, if you get on a roll or you're like, hey, this is a really cool idea, and you decide that you want to collect all the data about that, go for it. I don't care. But I love it when people do things that they care about because they tend to be a little bit better projects. But this is just the lab. It's not a project. So just you do you. All right. So you're going to need to organize your data into a frequency table. So take a look down here. I just highlighted it. There's a frequency table down here. You're going to have to do this manually. So there are ways to do it otherwise, but I'm not going to get into that. There's ways to count certain words in this, but we're not going to go that deep. So I just typed in green, blue, red, brown, and pink, and I counted how many of each one there were and created my little frequency table. You will need the frequency table. So let me show you. Now's the place where I'm going to show you how to make your pie chart. I'm going to highlight both of these right there. I highlighted both rows, and just do that by just holding down your the left clicker on your mouse, or if pushing down on your trackpad or whatever you're using and just holding it down and dragging it. So I have those highlighted. Click on insert, and then recommended charts almost always will give you the right chart. Otherwise, you can just choose the one that looks like a pie chart. So I'm just going to go to recommended. See how this has a beautiful little chart title right there? All right. So there's a couple of things wrong that I don't like about this, but let me choose my style first. Because the problem is, if I change the style of my graph after I make changes of things like what color my slices are, it's going to change them back. So I need to find the chart style I like and then go and do the cosmetic stuff. I like to have, and I want you to have, percents on your pie graph. So click a chart style that has percents. This one's good. Or there's this one right here. Choose a chart style. This one's good. I like the black background. Choose one that has percents on it. And that's another good one. So just pick one that does. Oh, I don't like that one. Anyway, okay. I could do this all day. And then you're going, oh, how about that? Ew, that's ugly. Okay, sorry. Anyway. And then you're going to need a chart title, and I don't care what you call it, but if you don't have a title, you're going to lose points. So make sure you have something. Favorite colors of friends.
Right? Are you saying like the color of the friend?
Yep. My friend, I like pink friends. I
There
like
you go.
green friends. I like red friends too.
Yeah.
I'm Native American. I'm probably red enough, I guess.
How about those purple? I don't guess I don't have it. I do have purple friends. Why aren't they even on there? What the heck happened to my purple? I don't know. Let's pretend that
Oh,
I somehow all of my data isn't correct over here. Let's pretend it's correct. All right. So now I have the chart style that I want, and I definitely want to fix this. I'm going to double click on it. When I double clicked on it, I get this lovely thing right over here. And I can start doing stuff. So I want this box.
mhm.
I want to start changing things, my slices. I might have clicked on the wrong one.
Kind of to the right color that you want it to be
Yeah,
representing.
I want to change my colors. Let me do this again. I think I need to,
Melissa,
yes.
so after you hit insert,
Sure.
what did you hit? What button did you hit to get your graph? You went to insert
I
and
went
then,
to insert and then I went to recommended charts.
okay, thank you.
Yes. Okay. So this particular one is green, so I want it to be green. This one, oh, I didn't want all of them that way. Ah, okay. My goodness. See, I've never had this much trouble before.
You will all like green, and that is the only color.
Everybody is green. There we go. Okay. Everybody's green. But it ain't easy being green. Okay.
It's not,
red.
it's cheaper not to be green.
You're having way too much fun.
You know what? If you can't have fun, what's the point?
Math is fun, y'all.
Yeah. Okay, there we go. So I changed them so the colors, even though they're ugly, they match. And so there I go. There's my categorical.
So now when you bring that chart down, it adds the percentage in that it was supposed to be, right? Like, I mean, I guess it's a little bit small screen for me to read.
Okay,
Guess
let me,
I'm getting
hold on.
old here, but-
Hold on. There we go. Yeah,
So it puts the percentage of what your data was that you highlighted.
yes, it
Correct.
will calculate it for you.
And yeah,
Oh,
you can
okay.
go back and change the numbers over there, and it will change the pie chart.
It'll pay the
I can do that,
like
yeah.
if you made them all green,
like-
right, it would just
that
make
made
the
it-
whole pie chart 100%
see, I
green.
just changed red to 12 and it just changed it for me.
Oh,
So
okay.
change it. Let's say, I'm going to say that I have 17 people that like brown because suddenly everybody likes brown. And it's
Right.
probably because Taylor Swift decided she liked brown. So that means everybody in the world does too. Because that seems
No,
to be what happens, you know?
this is not, ma'am. You're mistaken. She's a Chiefs fan, I guess. Even so,
Oh, so it has to be
she
red then.
makes bad choices.
So now I have to have 50 people that like red because suddenly now
Oh,
that Taylor
no.
Swift's a Chiefs fan, everybody likes red.
Oh no.
Like a Pac-Man.
So see, if I change those numbers, it changes. And my daughter is
Awesome.
the biggest Swiftie on the planet, let me tell you. For
Yeah.
Oh no.
she's 24 years old, but for Christmas, I got her a Taylor Swift coloring book, and you'd have thought that I got her something gold-plated. She was so excited. She's adorable. All right.
Awesome.
I'm going to do continuous data now before we get down this rabbit hole even more. See, you guys are too much fun. I'm going to have way too much fun this term. Thank you for that. So, okay. Now I have my continuous data. My continuous data is magnitudes of earthquakes around the world. And yours can be whatever you want it to be. A lot of people use things like rainfall, or they'll do things like money. You could do things like ticket sales, whatever. You could do how much Taylor Swift spent on feeding the homeless in different areas in the country. I'm just joking about throwing Taylor Swift out there again. It was a joke. Whatever you want it to be, whatever you want it to be, as long as it's continuous. Time is always continuous. Money is continuous. Most of the time, rainfall, things like that. Most weather things are continuous. Distance is continuous. So find some fun stuff. And once again, what's your population? My population is the entire world. The variable I'm studying is the magnitudes of earthquakes in different countries. Most of the time, continuous will have units. Unfortunately, I chose a bad example because I found out that magnitude isn't a unit. There's no units for magnitude. I looked. There's really not. And maybe there is, but it wasn't for people that aren't scientific. So, but most continuous data has units. This is probably, might be the only one of the three. And use the definition of continuous to tell me why your sample data is continuous. And the same thing on where you got your data. I want to know the name of the website, or if you polled people or whatever. Okay, I am not making you do this box here that I'm highlighting right now. You do not have to do that box right there. Because you don't need that to make your histogram. You do not need to use this box right here. Just FYI. If you want to, go for it, but you don't have to do that box. I'm not going to grade you on whether or not you did that box. If you do it and you do it wrong, I don't care. I'm not going to look at it. Okay. I'm going to highlight all of my data here. I have so many points. I have so many data values. I highlighted it and I'm going to insert. And once again, this one right here, this drop down will give you a histogram, but the recommended charts, it gave me a histogram. So I'm going to use the recommended charts. Okay. Most common error is the Excel will decide that it only wants to give me 2 bins or 3 bins. Don't do it. You're going to need to fix that. And I'll show you where, but don't allow it to do just 1 or 2 bins. You cannot represent your data with just 1 or 2 bins. Remember, we want basically between 5 and 20, probably closer to the middle of that somewhere is good. This is fine because I have 7. 7's a nice number, but I don't like my bin width, and I'll show you how to fix that as well. So before you start playing with things like your bin width and start putting chart titles, we need to make this what we need. Things that I need is I need to have axis labels on both my vertical and horizontal axis. So I'm going to go down here, up to the top left corner. Notice my mouse is up there. Add chart element. I'm going to add axis titles on horizontal and vertical because I need titles there. And then now I can change colors if I want. If I want a different color scheme, I could do different colors. I didn't do a different color. Yep, I could do different color schemes if I want. I like purple. Purple's pretty. You can make a black background. Make sure you do all of this before you do any fancy changing of things. Whatever kind of thing you want to do to your histogram, do that first.
So would this, in this continuous, would it always be a bell shaped, or
Not necessarily. You could be
I
skewed.
mean, can it be a Pareto chart? Could it be,
No. It can't be see, notice how I lost my axis titles because I've changed things. It will not be Pareto because it's continuous. So it is the
Okay.
smallest number to the highest number.
right.
So it will not be a Pareto. I'm not going to put chart titles, but know that you have to. Your axis title over here should be frequency. So let me see here, delete, put frequency here. Yes, it's really small. It's hard to read. How come it won't let me get rid of the word title? I don't know. Okay. So, and then your axis title down here, whatever it is, make sure you put that. You can change like the font size. I can go home right here and I could make my font size bigger. And I can make this font size bigger. I want you to play with it. The idea of these labs, a lot of it is so that you could play with things and try to see how it works. Because if you do Control Z or do the undo, you can undo whatever it is, ever mistake you made. I want you to play with them. Okay, I'm going to double click and open up this thing right here again. So right now it's on auto on bins, but I want my bin. I'm going to change bin width. I want my bin width to be 0.5. That's what I want my bin width to be. I'm gonna move this over so we can see it. So you can change your bin width to whatever you want, or let's say you wanted a certain number of bins. I want 8 bins. That works also. If you want the number to do the number of bins instead of the bin width, that's fine. It doesn't matter to me. I want you to play with it. So I'm going to make it 0.5 again, because that's what I like it. And let me tell you a trick. So, even though it kind of makes your data off, as long as you're aware that like, for example, if I change my 4.4 up here to just 4, it's still in the same category. So it doesn't change what my bins look like, or it doesn't change the size of the category, but it's going to make my bottom bin start at 4 instead of 4.4. So it's kind of cheating the system, but it's just so that my bin is going to start at the prettier number. Because all I'm really concerned about is how many are in that bin. Except for that, yeah, how many are in each bin, right? So as long as it's still within the same range, it doesn't matter. So I frequently will do that. I'll be like, okay, so my first bin will be, I want it to be 4 to 4.5. So I'm just going to change just this one to a 4, even though I know it's a 4.5. So take a look. Now it's nice and pretty, and I have 4 to 4.5. My bins are what I want them to be. Yeah, it's just kind of a way to trick the system. There's other things that you can do here that we play with it. And all I really care about is you getting your bin width, having the right number of bins, which would be in between 5 and 20. You can change a lot of things here. Obviously change colors. I can make it so that they have transparency different. Just play with it. Have fun with it. Questions about continuous before I move on?
I have a question. So this is the first time I've ever used Excel. So I see you have the questions, they're in the graph. So is that how we're gonna do it? We go
Yeah,
in and
you're
we
just
type in
gonna
the
type,
question?
like I can say,
Okay.
my variable, all I did was clicked on a box. My variable is the magnitude of earthquakes around the world. You could just type directly in there.
Thank you.
You're welcome.
And so I got a question about Excel as well too. I'm currently working off a borrowed laptop from a friend, but I do a lot of work I do a lot of schoolwork at work,
Uh-huh.
and at work they got Excel 2013. Do you know if all of this stuff's going to be in there, or should I maybe update my
Absolutely
Excel?
know that this will be in there because these are pretty much the same labs I took, had when I took the class. And I believe I took the class in 2011 or 2012. So
Okay.
it is in there. Yes.
Also,
Okay.
Yes, go ahead.
also, I don't know if you guys can or you could borrow a laptop from the RCC library.
I don't know. I don't know if you can, but I
Yeah,
know
they're out. They're
they're
out.
okay, but you
Yeah.
can use their computers, even if it was just for the labs, because we only have 5 labs. And so even if it was just for the labs, if you could pop in and use their computers, most of the labs don't take very long. They're pretty fast. And so you could always just collect all of your data and then just pop in and just take, 10 to 15 minutes to do your lab there. But I mean, the old Excel at work should be just fine.
Okay. Thank you.
You're welcome.
I have a question regarding the term continuous.
Uh-huh.
I feel like I have a pretty good grasp on it, but then I look back at the examples from Tuesday.
Uh-huh.
The household income in the previous year and the daily intake of whole grains. And I think I'm confusing myself. I'm thinking about continuous as being I think, and please correct me, because this is how I think it should be thought of as being infinite possibility.
Yes.
And
Technically
so,
it's infinite, but the thing is, okay, so it can take on values in between values. So like, for example, money. In order to earn $1, I had to earn 50 cents first, right?
okay,
I can't just I mean, technically they probably, could not pay you in partials or whatever. But, thinking about it in the sense that if I worked 1 minute, if it wasn't somebody who rounded to 15 minutes, I have to work 1 minute and earn that dollar before I can earn the next dollar the next minute. So it's kind of things that like build on top of each other.
okay,
And it's like, I'm not going to have, I mean, I guess I have to have 3 kids before I have 4 kids, but I don't have to have 3.8 kids before I have 4 kids. I'm going to have 3 kids or I'm going to have 4 kids. Now, let's not talk about pregnancy and all that, but I'm going to have 3 kids or I'm going to have 4 kids. I'm going to own 2 cars or I'm going to own 3 cars. I'm not going to own 2.87 cars. That makes sense, kind of?
that does make sense. But then when I look at the household income in the previous year, which is it's finalized, right? It's done.
Yeah,
It's
and I don't really like that example. If you just think about income, I would just think of it more as income. And I mean, and I guess I earned the money over the entire year. I didn't get all of it at the very end of the year. So it was a gradual increase throughout the year.
okay. All
That
right.
help a little bit?
Yeah.
Oh.
Can you break down the intake of the whole grains then?
Well, I'm not gonna just start the beginning of the day intaking however many grams. You have to gradually intake those grams throughout the day.
Okay.
And I can intake 5.87 grams. And I'd have to take 5 grams before I get 6 grams, 5.5 grams before I could take on any value between 5 and 6,
Okay.
And some of
Okay.
those aren't the best examples. I think things like rainfall and temperature are much better examples, but yeah.
Yeah, those are easy. Those do make sense to me. Okay, I'm just gonna keep workshopping this, but
Okay,
that does
all
make
right.
sense. Thank you.
This one's super fast because this one is the one where you really get to play. So
Guy, did you have a question?
yeah.
On the,
Oh, I was just
on
gonna
the-
make a remark. I think that maybe body weight is a decent example of
Yeah.
continuous. Because you eat food, you drink water, you pee, you go to the bathroom. It's kind of like in and out. It's a fluctuation. It's not necessarily you weigh like 150 pounds like every single second day of your life. It kind of goes up and down
Yeah.
by grams and ounces.
And you're not going to jump from 130 pounds to 150 pounds without hitting every spot in between at some point.
Right.
Mm-hmm.
Okay, that's good. I appreciate that, Guy. Thanks.
And then
Okay.
just to confirm the graphs that you showed us, the first one is sorry, I can't pronounce it, the categorical or whatever.
Yeah, this one's
Right.
categorical, the pie graph.
And the second one's the continuous.
Yes, this one's continuous.
Perfect.
And
Thanks.
the last one's going to be discrete right here. So discrete are numbers. They're numbers that don't take on every value. If you were graphing them, you would lift your pencil to graph them. So I did fictional number of children of fictional friends. And so they're just, this is data I made up just for this example. You should actually collect data, but I made it up. So my population would be my Facebook friends again. I'm studying how many kids they have. There's, like most of the time, there's no units for discrete, but there could be. It could be units. So you need to think about that, whether or not there are units. Remember, units are like feet, miles, days, things like that. That's units. So dollars. So you need to decide whether or not you have units for your data. Use the definition of discrete to determine how you know that your sample data is discrete. Also, same as the others, tell me where you got your data. So this one is completely you figuring out what graph you like and what graph represents your data well. You can go through all of the graphs that we have, take a look, so you highlight your data or use the frequency chart. You can use the frequency table, or you could just highlight your data and play with it. Try the different kinds of graphs. There's so many things here, so many different kinds of graphs. I want you to find something that you think represents your data well, whatever it is. I don't care what kind of graph you end up with. I want you to find, I don't know what these are. What are these? I don't know. Okay, wait, sorry. So just play with it. Find something that you think represents your data. And this is for you to get creative and you to play with the tools and just poke around. You're not going to break it. However, it might not be a bad idea to save the first two before you start playing with the third one. But regardless, just play with it. That's the third one, is just to play with it. All right, I'm done. Unless you have
So one second before we stop recording, how do we save all of this? I mean, I'm assuming just home and save,
yeah,
kind of like you would any Excel document, right, or anything.
Right. I prefer you save it, like put your last name with it, because as I'm opening them and grading them on my computer, sometimes I have like 3 or 4 up on my screen, and knowing whose it is helpful. Otherwise, I have to close them all out and go directly to it and reopen things. So if you can save it with your last name, you could just say, like mine would say Kleiss Lab 1. That makes
Right.
life a little
And
easier.
you just go to home and then save.
Yeah, you just
and once we've saved it in the lab part, you'll see it. We don't have to upload anything.
No, you have to upload it. Let me show you. I'm going to
Okay.
show you where to go. So I'm in my content here. Let's go in there. Assignments and lessons. I'm in week 1. I'm going to open it as a student.
Mine will be labeled Guy Hughes for most of the term.
Perfect.
Just so you know.
All right. So
I think you mean I need to label mine Eddie Sankey.
Hey, that I might be okay with that, Guy.
Okay. All right. So okay.
You're a
So
smart dude. You good.
You guys are funny. All right. So when you go into the lab, this is what it looks like when you go into the lab. Here's where you download it. When you click on this, it'll open. So here, save it on your computer somewhere. Pay attention to where you save it on your computer, because there's been so many times, I know personally, there's been so many times that I have uploaded something or like saved something to my computer. And then I'm like, where the heck did that go? And then I have to go in and try to save it again to see where that sent the first one. Yep. So pay attention. So you're going to need to attach a file. So you'll click right here. I don't even know if it's going to let me. So when you are done, click on choose file, and then choose the file that you are saving, wherever you saved it on your computer. I'm going to pick something random. Let me see here. I'm sure that there's a download or something that I can save. I'm going to pick something random. Here we go. And then I'm going to save it there. It should show that it's there. And then you're just going to hit submit. You don't need to do the add work. The reason I throw that on there is because every once in a while someone has problems uploading their work right here. And then you could just attach it here instead. Because every once in a while there's trouble. That's the only reason I have the add work there, is just in case there's issues, then you can just attach it here instead. And then just submit and end. And then now let's say that you uploaded your lab and then you're like, oh my gosh, I forgot to do the categorical data. I did the other two, but I didn't do categorical. You can redo it and then click on retake right here and then do it again. If you click on retake and do it again, I can see every entry you put in there. And I would like it if you retook it. If you submitted another one, you can type in here and say, this is the one you should grade.
Okay.
Please, if you upload like 5 of them or something, please let me know which one you want me to grade, because I mean, I can poke through them and find out which one's best. But if you want me to smile and be like, oh yes, thank you, please type that in there and say, this is the one you should grade. And otherwise I'm going to assume it's the last one, but you just never know. All right. Other questions?
So Melissa, we'll be uploading, we're uploading 3 at least,
You're only
right?
uploading 1 because they're all in one file.
Okay.
They're all, see, notice how,
On the
so,
bottom, there's 3 pages.
yeah, let me move this. So notice, see here, there's 3 pages here, the little tabs down at the bottom.
You can add another
Yes.
one with that plus symbol down there.
Yeah,
So
if you wanted to add another one, I mean, like maybe you're like, oh, wait, look, I have another cool, really cool graph. Let me just throw this other cool graph on here. I don't care, but you can add as many sheets as you want, but there's 4 sheets. One has the instructions. Notice the instructions say 50 elements. Basically, it's a reward to people who actually watch the instructional videos or come to class that only end up having to do 20. So it's kind of, that's what I do. I reward people. So then so you just click on the little tabs to move from one to the next.
Got it. Thank you.
So you're just uploading one. All right.
And so, and I was distracted at the end. On the discrete graph, the graph that you put, it's the frequency one. Is that what it's going to
No,
show up as?
you choose whatever kind of graph you want. On the discrete is where you're going to get creative and you're going to poke around and try different graphs and see what you like and just choose one.
Okay. Okay. Thank you.
That's the most fun for me to grade because I get to see everybody's creativity.
Thank
All right.
you.
Anybody else? All right. It's been really awesome. Okay, I'm going to quit recording now. Stop.